VSR value is 5. VR theta is 30. Let me keep value. So this will be W is 10 meter. 10 meter. I'll write down all the values.
Sir, W by VSR sin theta.
No, look at once. I changed the diagram. No, you can't. That's why I told you. No, in physics, just like, sir, I know formula, I'll manage. No, based on situation, you work out. Okay, theta. How is theta? Theta with respect to vertical, I took here. No, not getting
Understood, sir.
formulas. Things will change. You can't just stick on to then particular theta. What happened with respect to normal? I put it. So therefore, time taken is equal to W by VSR cos theta. W is 10, VSR is 5, theta is 30, cos 30. So this will be 10 by 5, so 3 by 2. So time taken will be 4 by root 3 seconds. What about the drift? How to calculate drift? Drift should be equal to VR minus VSR sin theta. Straight away I'm writing you try to see that one. Like yesterday, what we discussed, that only we are applying it. So x equal to velocity of river. Velocity of river 10. VSR is 5. Sin 30, 1 by 2. So this, what is the time taken? 4 by root 3. So this will be 10 minus 5 by 2. So 4 by root 3. Okay, this will be x is equal to anybody value x equal to I will write it here. It will be easy for you to view also. What is the value of x? X is equal to 10 minus 5 by 2, 4 by root 3. Okay, what is the value? Anybody simplified one?
17.32, sir.
Plus, you will get it, no? Positive.
Yes, sir.
17.32 meter. Okay, now, looking at the data, you tell me like it. Where do you reach? Though it seems up the stream, so there's a river current, there's the width of the river. The river current will push him so that he will, this will be VR, and he will reach down the stream. This is the drift. So this is the end point. After what time is here? 4 by root 3 seconds. So try to see now, everything is available here. With respect
So they
to,
have given that root 3 is 0.6, no, sir. 1 by root 3.
okay, we'll substitute that value. Root 3 is 0.6, no? 1 by root 3. 0.6 into 4 will be 2.4 seconds. In terms of that. Okay, try to see this all. So now, what is the drift? Drift is positive. No? So what is this path with respect to ground? You ask this swimmer where he is heading. He said that I'm heading towards B. The river current will push and he will finally reach at point C. 50 meter. Check calculations once. Is it okay? So now, what is this VSR? Velocity of swimmer with respect to river. Shall I also call this as velocity of swimmer with respect to river in still water? Both are same. No? Velocity of swimmer with respect to river. VSR. What is the name for VSR? Will give velocity of swimmer with respect to river, flowing river, or with respect to still water. Both are same, sir. How come suddenly you are changing the sentence? So I'll this is something in books it's really troublesome. Velocity of swimmer with respect to river current or with respect to still water. Both are same. This is really will trouble you a lot. This particular thing, sir. How come still you are bringing? Is it possible for the river to be still? No, not there. No. So what do you mean still here? Actually, if the person, the boatman will it's a swimmer. No, let's take the boat. That one. The boat is moving in the river. Then if you check you ask the boatman if he's moving with a velocity VBR in a river. You ask the boatman. He feels the flowing river at rest. That's why this is brought here. It doesn't mean that it's the absolute velocity. Are you getting no? VSR, velocity of swimmer with respect to still water. Any reason for that? See, what is this is VS. Look at this one. What is VS? Velocity of swimmer with respect to ground it is. What is VSR? Velocity of swimmer with respect to river. And if you stand on the bank, how you feel? River flowing towards right. So this is one thing. You have plenty of numericals instead of showing writing like this, no, with respect to river current, they're saying still water. So don't get confused here. Both are one of the same. I'll just give you the idea what is actually meaning of. Okay, you stand on the bank here. For what you say, river is flowing towards right. The person who is on the boat, the boatman, when the boatman is moving with a velocity VBR, you ask him what is the state of river. For him, the river appear at first. For him, the river will appear because he is moving with a velocity VBR. So you go back to VAB. A and B are moving. If A moves with a velocity VAB, then B will appear at first. This is the one simplest basic condition. You may not accept this. Sir, you are telling some story. You are telling some story. So I'll just take you to. Okay, I'll give one. Already you know a little bit of relative velocity motion. So let's take as it. A is moving with a velocity. Already we discussed this concept. And B is moving with a velocity 3 meters per second. VAB, what you calculate? VAB equal to VA minus VB. Pi I cap minus 3J cap. So 3I cap. I'm giving simplest example. At least with this, you should be able to catch it out. Okay, now you ask him. So there's a person is there on the ground. You ask him. What will be his comment? A is moving towards him and B is moving away from him. Is it okay? So what this person or this person what he says? A and B are moving towards right with a velocity 5 meters and 3 meters per second. We'll ask A itself, a person standing on the A. When he looks at the ground, if he is with a velocity 5 meters. If I make A to move with a velocity 2I cap, or if I make him to move with a velocity
Sir,
VAB,
your voice is
Sir, your
cracking.
voice is
Sir, your
cracking.
voice is cracking.
I'll stop the video. Now okay? Can you hear me? Can you hear me? Anybody respond? Can you hear me clearly?
Yes, sir. Yes, sir. Yes, sir.
Okay, no, I'll continue. Yeah, fine. Okay, look at this. Now let A move with a velocity VAB. Though B is moving with respect to ground, how it will appear for him? B will appear at rest for A. Though B is moving for A, what happen? Person A, what happen? Will appear at rest. Because it's moving with a velocity VAB, no? Then B will appear at rest here. If they ask you drift, it should be like a not mod X, that one. Drift can be positive, negative, or zero, no? So based on that, what happen? You have to put a sign that one. If drift negative, okay, drift negative it will be. If it's a positive, it will be positive. Not mod, need not to tell that one. Because drift can be positive or negative. Okay, no. If the A moves with a velocity VAB, then what happened to B? B will appear at rest. But what actually B is moving, no? Are you able to get the logic here? Though B is moving, if A moves with a velocity 2 meter per second, then B will appear at rest here. Sir, how it is possible? You can try now. After what time they'll meet, calculate that. Similarly, the A will take same time to meet B. Then after meeting B, what happen? The A will cross. Here also the same thing will happen. There's the best thing. I said, okay, both A and B are moving. If the A moves with a velocity VAB, the B, though B is moving with respect to ground, but with respect to A, it will appear at rest. Shall I say that that chill water, same idea here? The same idea of the still water. If you stand on the bank, the river is flowing. If the swimmer swims with velocity VSR, the river will appear at rest. So therefore, I can use word still water. Doesn't mean that the river is at rest. Got it idea now?
Yes, sir.
Yes, sir.
That's the one best. See, you have to analyze here. So nothing called like a formula. In physics, you don't get anything. You should always take an example. So I'll help you with further few more. A moves. Both A and B are moving. Now also what happened? No, what he says, like a B is at rest. Who is saying B is at rest? When the person A moves with a VAB, then B will be at rest. Not like 5 meter per second. I just changed the situation. Actually, he will be moving. The B will be moving, but for him, what happened? He will still appear at rest. There's a thing here. But with respect to ground, they're moving. So therefore, since we are doing the frame A, no, so better you write it like this. This problem is with the in ground frame. The second diagram is in the frame of reference of A, we are showing this situation. In reference frame A. In ground frame. Okay, fine. Okay, now proceed in similar way. So I think already we got a formula, no? So what you are going to do here? Calculate T and X in every case and show what can be the possible values. Okay, work out, no? Just substitute VR and VSR sine theta. In this particular formula, substitute all this, then we'll check the diagram, how different cases the diagram will be. I'll come for second case. Okay, no, in the second situation, theta, there's a width, and there's a velocity of river. Anybody value? This is point B. VSR in this case is 10. Anybody, can you give me the values? T equal to?
Sir,
Yeah.
there's a disturbance in your voice. I mean, it's frequently repeating and
Could not hear me. Huh? Just
Sir, voice is breaking.
why is it breaking? Okay, I'll wait it. I'll wait it. Can you hear me? Can you hear me? Anybody, please respond.